All right, so here we go. We got 11.4 geometry, a little bit of an introduction into three-dimensional figures. 3D figures. A word I'm going to be using, and you might see in some definitions here, sometimes I'm going to use, instead of saying 3D, I'm going to call it a solid, but it really just means the same thing. I haven't done this for a while, but never too late to start. The things I want you guys to get out of this video to be able to do, the learning targets. Number one, I want you to just be able to classify these types of solids. How can we name them? Number two, describe cross sections. And I will define what a cross section is here. And then number three is sketch and describe solids of revolution. So we're going to be talking about solids of revolution, another vocab word to go here. All right, so the first word here is a polyhedron, and it's kind of a interesting word. What it really just means, it's a solid that is bounded by polygons, or it's completely enclosed by different polygons. And a polygon, remember, is just a shape with straight edges, straight sides. So to give a really kind of classic example of a polyhedron, we're going to use a prism. And a prism is also kind of what you think of as a box. And I'm just going to make two rectangles that are the same, and then I'm going to connect their vertices there. And so here we have a polyhedron. And again, that definition, we call it just a solid bounded by polygons. Something that it doesn't have polygons, like a sphere, which is rounded, that's not a polyhedron. We'll talk about that a little further down here. A face, well, a face is just one of the sides. So if I take this first rectangle that I created here, and I just want to kind of scribble it in here so you can see, this is the face. And it's basically, you can think of it as a polygon from the solid, from the three-dimensional figure. The edge is the intersections from the polygons, and an edge is always a line, so, or a segment, excuse me. So segment formed by intersections of the polygons. And then next one here, sorry, skipped, went down way too much. A vertex, well, that is just a point here. Here's one, here's one, here's one. And that's just a point where three faces, or the three polygons, intersect. So it's kind of similar to when we're talking about a vertex with a two-dimensional figure, which is always just the intersection of the two segments. Well, the vertex of a solid or three-dimensional figure is where three faces are intersecting. Now, a cross section is the idea if we took, so the actual definition is the intersection of the plane and the solid. So I'm going to draw this as best I can. Intersection of plane and solid. So if you have like a square here, or let's Yeah, let's make a square, let's make a cube. Like so. And we're going to take a cut out of this thing. We're going to use a plane, and we're going to draw the plane kind of through it. So it's going to come through here. It's going to cut through that one. Let me make it look a little bit more like a plane. So it's like a two-dimensional figure that is cutting through. And it's cutting through here, here. You can see that it cuts through. It's like this little gray area right here. That's the cross section of that cube. And you're going to have to be able to describe those. So a lot of the cross sections are always two-dimensional polygons, or they're just polygons. So cross sections, another note, are polygons. So like you'll see the cross section here is a parallelogram. And we'll do some more examples of that. Another way to create a solid is if you turn something around an axis. So let's say you had like a square here, and then you had what is called an axis of revolution, which is this word here. And let's say you revolved something, this square, this rectangle around it. So you kind of going to start to see that if you rotate this around it, it kind of creates this shape here. And this is how cylinders are created. So it's like you have a solid, like take my phone like this, and you rotate it around something, you're going to end up creating a cylinder. And so that is a solid of revolution. And examples of that, like I said, cylinders, cones, and those things are not polyhedrons. Because they don't have polygons bounded by polygons. Okay, so a few more notes, and then we'll do another video with examples. So now classifying polyhedrons, or types of solids. So a prism is something that has a base that is two similar bases. So like if I have a base that is a rectangle here, I have that same base that is opposite of it. So that is a prism. You can have these with square prisms, rectangular prisms. You can even take like an octagon, put another octagon on that side, and then connect those points. You can have one that's a heptagon, hexagon, and you call those prisms like hexagonal prism. And we'll look at some more examples of that in a second. Another type of polyhedron is a pyramid. And that's when you have a base, but you don't have the same base opposite from it. In fact, that base has other polygons that just come to a point. Okay? So these are types of polyhedron. Something that is not a polyhedron, it means it doesn't have, all the sides aren't polygons. And you're going to notice this is things that are rounded. So non-polyhedrons are rounded. Cones, cylinders, spheres, they don't have a flat surface. And let's just write that. Not bounded by flat surfaces. And really it's that idea of not bounded by polygons. Okay? Another idea of I just want to kind of do this one. Let's say I had example of a prism Let's do an example of a hexagonal prism. So you can just kind of see. So let's draw a hexagon. So I'm going to make 6 sides. And then I'm going to draw another hexagon. And it has that really can try to make it the exact same. I'll do my best here. And now I'm going to connect a bunch of stuff. So I'm going to connect this to this. Here, let's make it a little off center. Let's do that one more time. So I'm going to draw one of them here. And then let's draw one of them up here. And again, this isn't great, but it's the idea that these are all going to be connected. And it's creating a prism. And it's because it has the same shape as opposite sides. If you had another example, let's do it that same hexagon, but a hexagonal pyramid. That would be that hexagon, that same thing. So let's say it's here. But then let's say they all the sides come to this point. Like so. So that is a pyramid. And you can have these prisms and pyramids with all types of shapes. Like I said, you could make a heptagon and then another heptagon and then connect them. That's a prism. Or you can make a heptagon as a base and then all of them go to one point. That's a pyramid. So that's how you're going to be able to describe those. Okay.